In today's video, we're going to be taking a look at page 8 in our Unit 9 packet. Now, at this point, you should have taken some time to read over both pages 6 and 7. Just a real quick overview, page 6 goes over our properties of acids and bases. And it also talks a little bit about different ways we can measure pH in a lab using litmus paper, which gives us just a generic acid or base answer. Using indicators, which again can give us a color change at a different pH range, or using a pH meter. And then page 7 goes a bit more into what our pH scale is. That when we talk about the strength of an acid or base, we usually talk about the concentration of that hydronium or hydrogen ion, where again that H plus is hydrogen and hydronium is H3O plus. And it kind of goes into how pH of 7 is neutral, less than 7 is acidic, greater than 7 is a basic solution. And then it kind of goes into some other formulas. Now, I would make sure I know these formulas. You definitely want to know these for calculating pH or finding the concentration of these ions. And what I want to focus on page 8 is actually using these formulas. So, let's get started with number 1. So for number 1 on page 8, we have a 0.000010 molar solution of acetic acid. And the first thing that we need to know is what is our concentration of H+. So as we saw in kind of the examples up there, that first hydrogen right there, that's our acidic hydrogen. So when we are asked the concentration of H+ in an acid, that's what we want to look at. We need to see if there's any subscripts. There's only one, so that tells us the concentration of H+ is going to be the same as our concentration of our solution. So our concentration would just be 0.000010 molar. There's no 2 there. If there was, we'd have to double our concentration. If it was H3, we would have to triple our concentration of H+. So now we're asked, what is the pH? Okay, so remember our formula for pH is pH is equal to negative log of our H+ concentration. So in this case, it would just be negative log of 0.0000, I think that was 4 zeros, 10 molar. So into our calculator, we just go negative log, make sure you use the log button, 0.40, 10, and we'd get a number of 5. But pH can be a bit tricky with significant figures because the sig figs in pH come after the decimal. So our concentration there has 2 significant figures. So again, sig figs in pH come after the decimal. So 2 sig figs would be 2 decimal places. So the pH would be 5.00. Okay, question number 2. We have 0.000030 molar aluminum hydroxide. 2a asks us, what is the concentration of OH minus? Okay, so here we have to account for our subscript. When we put aluminum hydroxide into solution, it's going to dissociate, and we're going to wind up with 3 hydroxide ions for every 1 molecule of aluminum hydroxide. So to get the concentration of OH minus, we got to multiply by 3. So 3 times 0.000030 would be 0.000090 molar. Again, we multiply that concentration by 3. And then to get the pOH, again, P just stands for negative log. So we take the negative log of that hydroxide ion concentration. So we take the negative log of 0.000090. Again, so negative log of that. Typing into my calculator. And this time we do get some decimals. And we should have 2 decimal places because there are 2 sig figs. I get 4.05 as my pH. Or sorry, pOH. 4.05 is my pOH. So then in my next question, I'm asked to find pH. Okay, so we have a relationship here, one formula to know. Our pH and pOH for a solution always have to add up to 14. So if we know the pOH, we can just plug it in. So pH plus 4.05 equals 14. So I'm just going to subtract 4.05 from 14, and I get my pH as being 9 point, sorry, let me just rewrite that, 9.95. So follow-up question for number 2, acid or base? Well, it's a base. The pH is 9.95, it's greater than 7, so pH is a base. And one thing I should say, again, we don't worry about it too much in honors chemistry, is that our pH is a logarithmic scale. So what I mean by that, let's see if that's on the prior page. No, it's not on the prior page. What I mean by saying it's a logarithmic scale is that every time the pH scale changes by a factor of 1, it means our concentration is changing by a factor of 10. So notice here we have a pH of 5 for this acid. If a pH was 4, its concentration would be 10 times higher. If the pH was 3, it would be 100 or 10 to the second times higher. It's just a fun fact to know. All right, let's try a couple more. So number 3. Number 3 asks, what is the pH of a solution with a hydrogen ion concentration of 2.3 times 10 to the negative 6? Okay, we're asked for pH. Okay, hopefully we're starting to memorize this by now. Remember, our pH is found by taking the negative log of our H plus or H3O plus concentration. Oh, guess what? We're given our concentration, so this is just a case of plugging in. So to find our pH, we just take the negative log of 2.3 times 10 to the negative 6 molar. So I go negative log 2.3 times 10 to the negative 6. And again, I would want 2 decimals here because I have 2 sig figs, so 2 decimals. I got 5.64 as my pH. So another acidic solution because the pH is less than 7. All right, number 4. Let's just keep doing another more of these. A couple more. Number 4 asks, what is the pH of a 0.00010 molar sodium hydroxide solution? So we know pH is negative log of H plus. So for number 4, we might be really tempted to just say, oh, pH equals negative log of that concentration. But there's a catch here. This is sodium hydroxide. So that concentration there is actually going to be my concentration of OH minus. So this is a 2-step problem. Now I know pH and pOH equals 14. So if I can figure out one of those, if I can get either pH or pOH, I can get the other. So for number 4, I'm going to find pOH. Because again, the concentration I have is a base. So I'm going to take the negative log of 0.00010 molar to get my pOH. So negative log, I think it should be 4.00. Again, even though it's exactly 4, I want to show my sig figs with 2 decimals. Then I can plug that back into my formula. pH plus my pOH equals 14. So let me subtract those two. 14 minus 4, and I get my pH as being 10.00. All right, not too bad. You just got to make sure you pay attention to whether you have an acid or a base to start with. All right, let me just try one more here. So number 5, we want to know what is the pOH of a 0.00010 molar magnesium hydroxide solution. Oh, 1-step problem. Take a look. pOH and an OH minus. So all I have to do for this is just take my negative log. Right, just negative log of 0.0010 molar, right? one thing to watch for. Again, we have to account for any subscript with H plus or OH minus. That's going to change that given concentration. So because we have two OHs, we got to double that concentration. So to find our pOH, it's just going to be negative log of that concentration doubled. So it'd be the negative log of 0.00010 times 2. And that would give us our pOH. So my negative log of 0.00020, and I get my pOH as being in two significant figures, so 2 decimals, 3.70. Try number 6, see if you can get pH and pOH on your own, and I believe the answer key will also be posted.